Hi everyone, this is Elof. Welcome to this tuto on how to build the first stage of the Foundry Gauntlet Revision 1. So let's jump right in. I will just present a little bit the gauntlet before jumping in. So the gauntlet is accessible from the main menu. You can be on main and on experimental. Just be sure that you have the 125 version and you should be good to go, so you can just click it and access it. The main thing you want to take a look at is the leaderboard, and there is rules as well, so let's just see that. It's updated every 5 minutes or so, with submission taking like up to 30 seconds to come in, so you can have like up in maybe 5 to 10 minutes you will have your position updated in that leaderboard. So we are starting the week 0, so Dlatch challenge, and I will walk you through a simple Dlatch. In fact, I will just do the Dlatch of subprocess. So subprocess and process prime are references. We use that to have a scoring system because our chip is an open-ended puzzle game. So it's important to have like a low reference and a high reference, and it will determine how the score will work for everyone. I won't show the best one, of course, even though it's not the best one anymore, but I will walk you through this subprocess submission. So without further ado, let's go into it. So this is the regular editor. I will just show a quick round of what it is for the people who don't know. You have your power lines, positive and negative. You have your inputs and your outputs. On top here you have your truth table, so you can have all your test case you need to do with your circuits. Bottom left is just information about mode you are in, on the redo stack, slots, all the good thing, blocks in the middle, and camera control. And you know what? Camera control, I will just get rid of those because I like having this part of the screen empty, because I know the control on the keyboard. So we are going through the subprocess, so the reference, and the reference is always following that type of blueprint. So if one is provided, it will be the one used for determining the baseline. So I'll just do that. So there is many ways to do a Dlatch, and I encourage you to find new ways to do it. This is not the only way, far from it, but I will do this one. So it's a variant with 4 NAND gates and 1 inverter, and yeah, that's pretty much it. So I'll just remove everything, and I'll put first a NAND gate. So it's quite a big one. You can have smaller one, but I'm using naive NAND gates. The only difference is they are not merged. Every naive solution must follow like some type of rules, and this is one of them. But it's composed of 3 transistors, and it's quite simple. Input A, input B, and output. And we need 4 of them, so maybe I will just put this a little bit there to keep the space for my inverter, and then I put naively my 4 gates as described in the blueprint, the schematic, sorry. So that should do it. We'll do maybe a little bit of cleanup. So let's remove that with Alt button down. I can even do that. So it's a little bit clearer. Let's remove that. And then maybe this, that. Alright, that should be good. Let's go this way. And we'll connect like that. I shouldn't do that first, but you know, I like to do stuff the proper way. So we have our 4 gates and they are connected. Maybe I can just put that there and launch the simulation. Everything is plugged in, so that's great. Now we want a NOT gate. Let's put that. Oh, it's a small one. I will use the one from the campaign, so it's called compact inverter. Yeah, that's better. Let's put this here, and I'll put my in there and my right over there. So my idea is in is there. I need a direct line to in, and I need an inverted line from in. So let's go with that. I can just take this one here, and the inverted one I can bring that, I guess, here, or the bottom one would have worked as well. Let's go with the right line. So I need to plug this here and there. I'll do simple connection like that. Yeah, I think I could do better, but for now it will do the trick. So if I power that up and put 0 on my inline, I have this that is properly connected, and the inverted is going properly into the other NAND gates, and we have everything that's working fine. This is connected properly as well. So now I have the top left NAND gate, and I want that plugged into the next gate. So let's just do that simply with that. Yes, so try not to plug things around. Be careful when you draw a line, because sometimes it will plug into things that you are not aware of. And then the bottom NAND gates, we need to plug this one into here. So like that. And now the last line of NAND, the last column, I should say. So top right, the output is the output of the gate, and the output of this gate must be fed to the other NAND. So I could just do that instead of connecting myself here with that line of the gate and the metal trace. I can just plug myself the other way, and I need to have this. So little trick, you can do that and select segment, and it will select the entire connected segments of like continuous metal trace, so it's really easy to see where you are plugged in with that that function. And if you don't satisfy, you can just remove the entire section. It's quite efficient also if you want to, for example, remove this entire thing. You just unplug it from everywhere and then you can remove like that. But right now I don't want to do that. Yes, better. So we wanted to have this output plugged here. So I think my best bet is just to take this and go around here and there. So now if I select this, I should be connected to this side. So that looks okay. Okay, better. Control Z or undo if you make a mistake. It's quite easy to do some mistakes sometimes. So we have something that resembles something that should work. So let's try that. We have our first test case. So it's writing a 0, everything is powered on, so that looks great. And then if we do nothing, we still have the 0 value from the cell. I'll put that big. So the third case is we know push 1, but we are not setting the right flag to 1, so the cell doesn't change its value. And then the test case 4 is we push 1 and we want to write 1 because the flag write is set, so it should change the value. And then if we go back to in 0 and write 0, the value of the cell shouldn't change. So that works great. 6 case, we are writing back 0, so it should change the value. Great, it does. And then we just settle in to 0 again. And we can do the last stage by hand or clicking on it. But yeah, typically we can change this value as much as we want. It won't update the cell's value, but if we have the right flag set to 1, it should take whatever the value of in is. So this is updating just perfectly. So we have a working solution. Let's validate that and see how it performs. Yeah, great. So now we have a working Dlatch ready for maybe next week, or we can do some optimization. So let's try to do some optimization. So maybe if I look at the score, I'm playing right now as Eloth. You can see that my best submission was 583, 447, and 1881 for 18 moss. So quite a lot of ticks, quite a lot of block, volumes and moss. Let's try to do a little bit better. How much I got? Oh, I did a little bit better. I did. I did not. Was tick. Tick is there. Oh, we can do a little bit better. Let's try. So I think here there is quite some space we can get rid of. So I will just try to remove these entire sections. copy this and paste like that. So what I'm doing is with the select, you can draw a square on the die, and then where you are satisfied of the size, you can press Ctrl, and then it will extrude the selection, and so you can select an entire section like that. So if you want to remove that central part, you can just do like that. And then after that you press delete and it will work. To reduce that, we just need to validate, and it will automatically reduce the size. So we didn't change quite a lot of... yes, we gain a little bit of ticks and a little bit of block and a little bit of volume. So we can try to maybe do one more optimization. How can we do that? So I think we can find some place here quite easily, or we could do something completely different. We could try to merge those two. So the idea is I have those two NAND next to each other, and they both need this power. So we can merge those MOSFET because they are the same type to get the same power delivery, and just do the mirror of the other one. So typically this one won't change the position, but this one we can select it. So I'll just remove two of it to prevent some, I don't know, weird stuff. Like when I will paste it, it will maybe overlap with something else, so I will just keep my input clean. Take this. So this is all selected, and now you can just cut, and then you paste. So it's the same, but now you can use shortcuts. So there is X that will flip like on the X axis, and then you have Z that will switch, flip on the Z axis. Do know that is X, Y, Z. The Y is upward, and the Z is like this direction. So what I want to do is this, and then I can just overlap this two like that. So now, so yeah, it's connecting. I have these two NAND that are partially merged in the section here, and the opposite side should have the logic of the NAND gate itself. So let's try to do that. So I will connect there, not like that, but like that. So you can flip the way you want your L to be connected. So I'm just holding left button, and here, for example, it's going down. I don't want that. You can, while still holding the left button, one click to the right button, and it will switch the L. And we'll connect that. It's a little bit wasteful. Maybe we can just do that then. Okay, that looks cool. So now we need to just plug it like before. So this one goes here, and this output needs to be connected there, and the bottom should be connected like that, and we'll just lower that. So let's try this way, see if it works. Yes, great. So we even gain almost 9 ticks, so almost 10. We gain 20 blocks, 21, so that's quite a big leap here. Volume, I didn't change much, but I think you see what I could do to even further reduce the size of the entire thing. Here you can see that there is 18 solution and 19, but there is like a group of people at this side of the graph. And in fact, if you go here, you can see the top ones have solution with 10 MOSFET. So I won't go into that in this video, but yeah, there is some space to improve that solution quite a lot. So even though it can feel like a bit challenging to go down to those range, I assure you it's possible. So that was all for this video. I hope it will help you get into the gauntlet and have fun, and see you on the leaderboard.